Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 10 of a unit System of Particles and Rotational Motion. So let's begin with today's class. In today's session we are going to see certain additional questions of the topic center of mass. So be ready with your pen and paper. Have your pen and paper with you. You will be having a question and you will start doing it. If you are not able to do it, I would be there to solve it for you guys. I hope this is clear. So let's begin and all the best. Let's have a look. The question says three particles of masses 1 gram, 4 gram and 5 gram are respectively at the corners of an equilateral triangle of side 10 centimeter. Then find the distance of the center of mass of the system from 1 gram. Okay, so what I want is that the situation is something like this. It is an equilateral triangle, something like this, and three particle masses are there. They want the center of mass of the system from 1 gram. Let's take it 1 gram over here, 4 gram over here, and 5 gram over here. So now I can take this as my reference line. So this is x-axis for me, this is y-axis for me, and this can behave as an origin as a 0 comma 0. The equilateral triangle having a side of 10 centimeters, so this would be the 10, this would be the 10, and this would be the 10. So if I write down the coordinates of this, it's a 0 comma 0, this is 10 comma 0. Now what about this? Yes, this could be written as 10 cos 30 degree, comma, comma, 10 sine 30 degree. It's a cos 30 degree and cos 30 degree and sine 30 degree, but it was a 60 degree, not a 30 degree. You made a mistake over here. This is 10 cos 60, 10 sine 60, because it's an equilateral triangle. This will make a cos of 60 degree. I hope this is clear. Is it clear? So if you know this, I can have the xcm and ycm and all that stuff. Now, so let's begin then. So my xcm would be written as m1x1 plus m2x2 plus m3x3 divide by m1 plus m2 plus m3. So my m1 was 1 gram multiplied by 0 plus m2 was 4 gram multiplied by 10 plus m3 was 5 gram multiplied by 10 cos 60. While I say cos 60, it is 1 by 2. It's a 10 into 1 by 2 divide by, the total is going to be divided by 1 plus 4, 5 plus 5, it's a 10 gram. So this would be 0, 4 into 10, 40 plus 2 into 10, that's a 5, 5 is a 25, divide by 10. So this is 65 divided by 10, which should be is equals to 6.5. I hope this is clear. This is the xcm. This is the xcm. It is at 6.5 cm. So in a same way, let's make it for ycm, which is m1y1 plus m2y2 plus m3y3 divide by m1 plus m2 plus m3. So this will be the 1 into 0 plus m2, which is a 4, multiplied by 0 plus m3, it's a 5, multiplied by 10, it's a 10 sine 60. So this is 10 multiplied by sine 60. While I write sine 60, it's an root of 3 divided by 2. I hope this is clear. Is it clear? Yes. divide by m1 plus m2 plus m3, which is a total of 10. So this is 5 5 is 25. This is 25 root of 3 divide by 10. It's a 25 into root 3 divided by 10. So it's 5 5 this is 5 2 so this 5 5 has gone, and I have been left with the 5 by 2 multiplied by root 3. This is y here. So the coordinates from the center of coordinates of the center of mass is the xcm comma ycm. That could be written as it is 6.5 comma 5 by 2 root of 3. I hope this is clear. So let me check what was the data asked. They asked the distance of the center of mass of the system from 1 gram. Okay, great. So whatever they have asked, what I need to do is that this is the origin. Probably this is the location. This is the location of center of mass. So I require this distance. How will I do this? That I am having this as a 90 degree. Yes, this as a 90 degree, and according to the Pythagoras I need to proceed. It is as simple as that. So let's just do it. It says that let's denote it by RCM. That should be is equals to xcm square plus ycm whole square. So this could be written as 6.5 whole square plus 5 root 3 by 2 whole square. Yes, if I'm going to solve this, it is root of 62, which is approximately 7.8 centimeter. That's it. I hope this is clear. Is it clear? Is it? So can you do this? Can you? Are you sure? Are you sure? Great. So let's work for the next question. It says a machine part consists of two homogeneous solid cylinders coaxially. Find out the distance of the center of mass from the O. Okay, how will you do this? This is the first machine part, and this is the second machine part. And I want the center of mass from this point. So what I understood is that this is a homogeneous solid cylinder. So when I consider axiom, look for the I need to look for the volume of the system. Yes, so I have written it as xcm, that should be equals to v1 x1 plus v2 x2 divided by v1 plus v2. While writing the volume of a cylinder, it is a area into length. While writing the area, it's a pi r square into length. So it would be a pi into r1 square into l1 into x1 plus pi r2 square l2 into x2 divide by pi r1 square l1 plus pi r2 square l2. I hope this is clear. So if I just try to solve this a little, this pi could be taken as a common, and that could be cancelled with this. Yes, so I have been left with the r1 square l1 x1 plus r2 square l2 x2 divide by r1 square l1 plus r2 square l2. I hope this is clear. Now they have given this data. Yes, so what I understand is that radius is given. This is my first system, as we discussed. This is my second system. Yes, the this is the radius is given. Length is given. Length of this. So length of this is 12 mm. Length of this is L1. This is L2. This total is of 20 mm. This has covered 12 mm. So obviously it's an 8 mm. So I am having an L1 x1. Yes, and the x1. Yes, so let's just put the value. It's a 2 square multiplied by L1, it's a 12. X1, it's a 6 plus R2 square, it's a 1 square into L2, it's an 8 into x2. I hope you understand from where I have taken this. Is it? So it is something like this, that this is the first cylinder, its center of mass. This is the first cylinder, and its center of mass would be lying at the midpoint. So if it is at midpoint, it is at 6. Obviously it is at 6 mm from the location O. While I talking about the second part, it's an L2 is equals to 8 mm, and its center of mass would be looking at this part. It's a 4 mm. Yes, it's a center of second part. But if I take a distance from here, this is O. This is already 12 mm. So if I take this distance, this will be the 16 mm. Got this? Yes, that's why this has taken as a 16. Divide by r1 square l1 plus r2 square l2. If I solve this, it would be a 52 by 7 mm. I hope this is clear. Is it? Is it? So can you do this? Can you? Great. Let's work for the next question. You are doing good job. Well done. Make it fast. It says a man weighing 80 kg is standing on a trolley which weighs 320 kg. The trolley is resting on a frictionless horizontal rails. It's a frictionless. Please keep this in mind. What is the displacement relative to the ground after 4 seconds if the man starts walking on the trolley along the rails at a speed of 1 meter per second? So person is moving with a speed of 1 meter per second. What would be the displacement relative to the ground after 4 seconds? Yes. So what I can understand is speed is equals to distance by time. So that could be written as distance, that should be is equals to v into t. What was the speed of a person? It was 1 meter per second. For how much? It has traveled for the 4 seconds. So the distance traveled is 4. Yes. So when I consider the distance, yes, when I consider the distance, that could be written as this is something like this. Yes, this is considered as a origin, and this is the mass m. So while I'm moving this, I can write like this. It's a d is equals to ml divided by m plus m. Yes. So it's a mass of a person, and this capital M, it is the mass of a trolley. So this d is equals to ml divided by m plus m, and this d could be written as 80 into 4 divided by 80 plus 320. That is the just the distance of point 0.8. So initially the relative distance it has been traveled, it's a 4 minus of d. Yes, because person is moving in this direction while trolley is moving in this direction. So if trolley has been moving in this direction, then what I can have is it's a 4 minus of d. It's a 4 minus 0.8, that is equals to 3.2 meter. Yes, this is one of the approach to do the question. Do you have any another approach for the same question? Do you have any approach? Is there anything? Is there? Even you can do this. Let's understand this, that this is the trolley, this is the man, mass of the man, it's an 80, mass of the trolley, it's a 320. If the man starts walking on the trolley along the rails at a speed of, if person starts moving with a speed of 1 meter per second, yes, if initially this system is at rest, and this whole system, this trolley has been placed over the non-friction surface, so no external force is acting on the system. If I take this as a system, as my boundary, then I can understand that there is no external force acting on the system. And if no external force is acting on the system, then I can say it's a P initial is equals to P final. Initially these two were at rest, it's an m plus m into 0. Then what I can understood is person has starts moving, so this is m of m into v plus mass of trolley into v dash, that I don't know. So this is 0. Mass of man, it's an 80. Its speed is 1 meter per second. Mass of trolley, it's a 320 into v dash. So it's an 80 is equals to minus of 320 into v dash. While writing v dash, this is minus of 80 by 320, which should be equals to minus of 1 by 4 meter per second. I hope this is clear. Is it clear? So this is the v dash. This is the velocity of a trolley with which it is traveling. I hope this is clear. Is it clear? So this is its velocity. Now for how long it had been traveled? Because person has traveled for the 4 second. Yes. So so velocity of trolley is equals to distance traveled by trolley divided by time taken. This is the velocity of trolley. Distance traveled we don't know, but time taken is 4. I hope this is clear. So what I can write is it's an lt is equals to 4 by 4, which is equals to 1 meter. I hope this is clear. Is it clear? Is it? Yes. Is it clear? Yes. Yes. No. Yes. Is it? Is it clear? Great. Now what you can supposed to do is that this is the distance traveled by 1 meter, but when the trolley has been being shifted in the negative x direction, while person is moving in this direction, trolley has been shifted in this direction. So what I need to do is I need to find out the velocity. I need to find out the velocity by certain variation. Let me rewrite this. One second, give me a moment. Yes. So when a mass of a man, when a person is moving in this, a trolley is moving in this, and only not only trolley, but person as well as trolley is moving in this direction. So this is 80 into 1. That should be is equals to 320 plus 80 into v dash, and this would be in negative. So it's an 80 is equals to minus of 400 into v dash. While I write v dash, it's a 80 by 400, which should be minus of 1 by 5. Yes, meter per second. So while doing this, we can have now velocity is equals to distance by time. The velocity it's a 1 by 5. Distance we don't know. Time it's a 4. So length is equals to 4 by 5, which is equals to zero point 0.8 meter. This is the displacement. This is the displacement of trolley. Now now let's just find out the displacement of person. Displacement of person. So displacement of person is L is equals to velocity into time. Person is traveling with a speed of 1 meter per second, and it takes 4 seconds, so it's a 4 meter. So so net displacement would be equals to 4 minus of zero point 0.8, which is equals to 3.2 meter. I hope this is clear. Yes, this is the another approach, but do not commit that mistake that I have committed over here. I hope this is clear. Yes, and you are not going to commit this. Great. So shall we move to the next question? Shall we? Let's look. It says that the question says that two blocks of mass 10 kg and 30 kg are placed along a vertical line. Okay. The first block is raised through a height of 7 centimeter. By what distance should the second mass be moved to raise the center of mass by 1 centimeter? So how will you do this? How will you do this? What could be done? What I understand is that we have this two blocks. One of the block is of mass 10 kg. Another block is of mass 30 kg. Yes, and they are placed along a vertical line. This is the vertical line they are talking about. The first block is raised to a height of 7 centimeter. If it has been shifted in the vertically upward direction with us by 7 centimeter, by what distance should the second mass, be moved to raise the center of mass by 1 centimeter? This is the question. So how will you do this? What I understand is that YCM is equals to m1y1 plus m2y2 divided by m1 plus m2. If I write this in a form of a change, what I can write, it's the delta YCM is equals to m1 into delta y1 plus m2 into delta y2 divided by m1 plus m2. I hope this is clear. Is it clear? Is it? Are you sure? Can we do this? Can we? Can we do this? Yes. So delta YCM, change in the YCM would be by the, so it says by what distance should the second mass be to raise the center of mass by 1 centimeter. This should be the one. My first mass, it's a 10, that has been shifted by 7 plus m2. I don't know about this one, that's why it's a delta y2 divide by m1 plus m2. This is 10 kg, this is 30 kg, this should be equals to 40. I hope this is clear. Is it clear? Is it? Yes. So this is equals to 40 is equals to 10 7 is 70 plus m2, it's a 30 into delta y2. Yes. So that is 40 minus 70, it's a minus of 30 is equals to 30 into delta y2. And if I'm trying to solve this, this delta y2 should be equals to minus of 30 divided by 30, that is equals to minus of 1 centimeter. While I am writing it in minus, I must understand that this should be moved, this should be shifted in the negative y direction, so that your center of mass can be shifted by 1 centimeter. Does it clear? Does it? What was your answer? Was it same? Was it? Are you sure? Great. Let's look at the next question. It says, as shown in the figure, from a uniform rectangular sheet, a triangle sheet is removed from one of the edge. Okay. Then it says that the shift of center of masses. They required the shift of the center of mass. So how will you do this? What is to be done? What I understand is that when they removed a certain part, what I can have is that delta x, that should be is equals to a1 x1 minus a2 x2 upon a1 minus a2. That is what I have written over here. Yes, that initially it is the initial system having a center of mass at this, so this could be written as a1 into 0 minus second area. Let's write the area of this triangle in a small a, multiplied by distance x2, it's a distance between this to the center of mass, this divide by the total area minus small area. I hope this is clear. So let's just calculate it. That this is the area 2. It's a 1 by 2 into b into h. So this is 1 by 2 into 20 into 30. Yes, this is 20, and this distance, it is 30, so it would be a 300. And what about the a1? The a1 would be equals to 16 to 20 minus 300, which should be equals to 900. The distance taken, it's a 2 by 3 into 30, which is equals to 20. So if I'm going to solve this, it's a minus of 6.67. While I write minus of 6.67, because initially the center of mass was here. Now this part has been removed, and as this part has been removed, center of mass has been shifted over here. I hope this is clear. Is it clear? Is it? Yes, it is just the calculative part that can take amount of time. Otherwise, conceptually, this should be very clear. I hope this is clear. Let's have a look one more question based on this concept only. It says that a square plate of side 20 centimeter has uniform thickness and density. A circular part of diameter 8 centimeter, that means this is the radius 4 centimeter. A circular part of diameter 8 centimeter is cut symmetrically as shown in the figure. The position of center of mass of the remaining portion is okay, great. So if this part has been removed, if this part has been removed, what we understand is, if this part has been removed, the complete system, if I look about the complete system, then the center of mass has been shifted in this direction. Yes, so the position of center of mass of the remaining portion, where does it has been shifted? It's a square plate of sides 20 centimeter. This is 20, this is 20. I hope this is clear. Yes, initially the center of mass was lying over here. So position of center of mass could be calculated as xcm. That would be equals to a1 x1 minus of a2 x2 divide by a1 minus a2. Yes, and it says a circular part of diameter 8 centimeter is cut symmetrically as shown in the figure. Yes, so so what I need to do is, it's an area 1 x1 minus area 2 x2 upon a1 minus a2. Yes, so from that what you need to do, area 1, it's an area of complete square plate. Yes, x1 would be considered as a 0, area 2, it's area of removed part, and x2 is the 0 to com of removed part. Yes, so just solve this and get it done. I hope you can do it. Yes, we have already done the previous question. Is it clear? Yes, yes, but that is for sure that center of mass would be lying over this. So at O1, not possible. Yes, zero point 0.8 centimeter from O on the right hand side, this is not possible. So what you need to do is, you need to check within this too. I hope this is clear. Even this can be done by you analytically as well. I hope this is clear. Is it? Great. Let's work for the next question. This question says that a uniform metal sheet is cut in the form of a letter T as shown in the figure. Find out the distance of center of mass of the split from O. Okay, this is from O. How will you do this? What could be done? What I understand is that, look at this. If you consider this as a first segment, if you consider this complete as a first segment, this is my first segment, let's say this, then this is the 2 meter and this is the 8 meter, and its center of mass may be lying over here. Yes, let's talk about the second one. it's a, if this has been considered as a first segment, this needs to be considered as a second segment. So center of mass of this system would be at the midpoint of this. I hope this is clear. Is it clear? Is it? Is it? Are you sure? Are you sure? So what is this location? What is this location? This is 2 meter, this is midpoint of this, so it's a 2 comma 0. This is the total length, it's a 6 meter, it would be at midpoint, so again this would be a 3 meter, and from this this is at, this is 2, this is 3, so this is at location of 5 comma 0. I hope this is clear. Yes, Is it clear? Is it? Great. Now what you need to do is you need to write down the axiom, which could be calculated as a1 x1 plus a2 x2, a1 x1 plus a2 x2 divided by a1 plus a2. The first area, this is 8 meter, this is 2 meter, so it's an 8 twos are, this is 16 plus second area, second, this is of from beginning from here and moving to here, it's a 6 meter, this is 2 meter, so this is 6 into 2 into, so this is this just a1 has been written, it's an 8 into 2, 8 into 2 into x1, it's a 2 comma 0, so this is 16 into 2 plus 6 into 2, 12 is the area, multiplied by x2, x2 is the 5, divide by a1 plus a2, it's a 16 plus a1 plus a2, it's a 12, yes. So this could be written as 16 twos are 32 plus 6 twos are 12, 12 fives are 60, divide by 16 plus 12, it's a 28. So this could be written as 60 plus 32, it's a 60 plus 32, which is equals to 92 by 28, and you can do the rest amount of thing. I hope this is clear. Is it? Is it? So can you do this? Are you sure? Are you sure? Great. Let's work for the next question. The next question says that it's two uniform roads A and B of same diameter having length of 2 meter and 3 meter. Yes, having mass per unit length. Okay. So let's say this is first joined end to end. This is second. First road is of length 2 meter. Another one it is having a length of 3 meter, and the mass per unit length, so lambda 1 has been given, which is m1 divided by l1, which is equals to 4 kg per meter, and it is having a length of 2 meter, so that could be given as 8 kg. And the second lambda, it is equals to m2 divided by l2, which is equals to 7 kg per meter. This is of 3 meters, so this is 7 threes of 21 kg. This is the mass. Find the position of the center of mass of the combined road from the free end of A. Yes. So let's just do it. Let me redraw the situation. That this is the situation. First and second. The first road is of 2 meter, another road is of 3 meter. We have find it out their masses as well. Yes, this is of 8 kg, this is of 21 kg. This is the origin. Yes, the center of mass of the first road, it is at midpoint, so its coordinates would be, this is of length of 2, that means its coordinate would be 1 comma 0 because of its midpoint. This is 3 meters, so this is at 1.5, but 1.5 from here, so total it's a 2 plus 1.5, so this is 3.5 comma 0. Let's just do it. It's an axiom that would be equals to m1 x1 plus m2 x2 divided by m1 plus m2. While I write m1 x1, it's an 8 multiplied by x1, it's a 1 plus m2, this is 21 kg multiplied by 3.5, can written 7 by 2, divide by m1 plus m2, it's a 8 plus 21. I hope this is clear. If I'm going to solve that, if I'm going to solve this, then this would be the, it's a 8 plus 21 7s, it's a 147 divided by 2 divided by 21 plus 8, it's a 29. So solve this, this would be the answer in, sorry, this has been given in meter, so even my answer would be in meter. I hope this is clear. Is it clear? Easier one? Yes. Yes. Great. So are you done with this? Are you done with this? Any issues, any concern over this? Is there anything? Is there anything? Is there anything? Are you sure? Are you? Great. So shall we move to the next question? Shall we? Shall we move to the next question? Great. Let's move on. It says that the question says that half of the rectangular plate of length L as shown in the figure is made up of a material of density rho. Okay, so this is my first material and it has been made up from the density rho, and the other half with density 3 rho. It says the distance of center of mass. It says the distance of center of mass from the O. So how will you do this? How can you? What I understood is that this could be written as xcm. This is equals to density 1 into x1 plus density 2 into x2 divided by density 1 plus density 2. If you wonder that how I could write this, what I understand is density is equals to mass by volume, and I can replace this with mass is equals to density into volume. Just the volume is going to be cancelled out, and I will be left with the rho 1 x1 plus rho 2 x2 divided by rho 1 plus rho 2. Now what is x1? It is just the midpoint. This is complete length. It is of L by 2, so this is at midpoint. Its coordinate would be L by 4 comma 0. And the second, it is L by 2 from this end. So from this, it's from 0. This point, it is at 3L by 4. So the coordinate of this, it's a 3L by 4 comma 0. I hope this is clear. So let's just put the value and get it done. This is equals to rho multiplied by x1, which is equals to L by 4, plus second it's a 3 rho multiplied by 3L by 4, that is equals to rho plus 3 rho, it's a 4 rho, which could be written as 5 by 8 L. Have you got this? Are you? Have you? Are you sure? Are you sure? Can we do this? Can we? Great. Let's work for the next question. Do it quickly. You are doing a very good job. Very good. Well done. Yes. It says that a U-shaped uniform wire of sides 2L and L. Yes. So this wire is of this side is of 2L and this side is of L. The x and y coordinates of the center of mass of each sides are shown in the figure. Great. The x and y coordinates of the center of mass of the wire are respectively. So what do you need? You need an x and y coordinates of the center of mass. So they have written everything. They have written everything. We don't need to do anything. Yes. What I understand is, let's understood that this is M, or this is side 2L, that means this is 2M. If I consider this as a mass M, this is 2M. What I need to do is, they have already written the coordinates. Yes, this is L by 2 comma 2L 0 comma L, and L by 2 comma 0. Yes, so this has been taken as an origin. So what you need to do is that just write down the xcm, which is equals to m1 x1 plus m2 x2 plus m3 x3 divide by m1 plus m2 plus m3. And the same way write down the ycm, which is equals to m1 y1 plus m2 y2 plus m3 y3 divide by m1 plus m2 plus m3. Yes, and that's it. Just put up the value and get it done. I hope this is clear. Is it clear? Is it? Yes, a very good question there, where we do not need to perform anything. Everything has been given by the examiner as well. Great, well done. So now let's work for the next question. What does it says? What is his idea of this question? Let's have a look. It says that two particles of equal mass have velocity of this and this. v2 v1 is equals to 4I and v2 is equals to 4j meter per second. First particle has an acceleration of this phi I plus phi j. while the acceleration of the other particle is 0. Great. The center of the mass of the two particles, the center of mass of the two particles moves in a path of. So what I need to do is, first I need to find out the velocity of center of mass, because I don't have an idea that where does it moving, and acceleration of center of mass 2 would be required. So let's just try to do this, and then we might get an idea that how the situation begins. So m VCM could be written as m1 v1 plus m2 v2 divided by m1 plus m2. So the v1 was 4i and v2 was 4j, so this is m into 4i. This is two particles of equal mass. It's a 4i plus 4j divided by m1 plus m2. This is equals to 2m. So this could be written as 4mi plus 4mj divided by 2m. This is 2i plus 2j. This is VCM. Now let's work for the ACM. It's an m1 a1 plus m2 a2 divided by m1 plus m2. While doing this, they say that acceleration of the second particle is 0. So let's write for the first one. It's an m into bracket phi I plus phi j divided by m plus m. It's a 2m. This 2 has been gone, and this is equals to phi by 2i plus phi by 2j. This is the ACM. So if I try to plot this, this is something like this. That let's suppose this is 2i plus 2j vector. This is VCM vector. Yes, even this would be the same vector in the same direction, phi by 2i plus phi by 2j, because this and this makes an angle of 45 degree with the x-axis. So even this would be the direction of ACM, and if velocity and acceleration both are acting on the same path, it would be a straight line. I hope you got this. Are you sure? What was your answer, or what was your approach? Was it same? Was it? Are you sure? Are you sure? So now will you be capable to do this? Will you be? Are you sure? Great. Let's work for the next question. Well done. It says that a uniform square sheet has a side length of 2r. Okay. A circular sheet of maximum possible area. A circular sheet of maximum possible area is removed from one of the quadrants of the square sheet. Okay. The distance of the center of mass of the remaining portion from the center of the original sheet is, okay, great. So this is the situation that, let's say this is something like this. Yes, and this part has been removed of maximum possible area. Yes, this is of 2r, so every quadrant will be of r, and maximum area, that means the diameter is r, or I could say it's a radius. Its radius will be equals to r by 2. Yes, I hope this is clear. So now from this we have already done this kind of question. It's an a1 x1 minus a2 x2 divided by a1 minus a2. That's it. I hope this is clear. Is it clear? Will you do this? Will you do this? Are you sure? Can it be done? Can it be? Great. So do it on your own. It's a try yourself. And we are moving for the next question. The next question says that it says a shell projected from a level ground has a range of r. Great. If it did not explode, okay, at the highest point, the shell explodes into two fragments having masses in the ratio of 1 is to 3, and with each fragment moving horizontally immediately, with each fragment moving immediately after the explosion. If the lighter fragment falls at a distance of r from the point of projection, the distance at which the distance at which the other fragment the distance at which the other fragment falls from the point of projection. So how will I do this? How will I do this? What it says is that the situation is something like this, that one of the projectile may be there, something like this, and it has been exploded over here, and it has been divided into two parts. One is the 1, another is the 3. Yes, it's a one could be of x kg mass, another would be of 3x kg of mass, and something like that. Now what does it say is that if the lighter fragment falls at a distance r from the point of projection, yes, from the point of projection, the distance at which the other fragment falls from the point of projection is, how will I do this? So one of the thing that you understand is that if it has been exploded over here and the lighter fragment has been reached to this is simply not possible, because the xcm is going to travel this distance. So the lighter part must move in this direction, and this should be the distance r. And if it has been moving this xcm, this is the r. Yes, xcm is this, so this 3x must be at somewhere here. I hope this is clear. Is it clear? Is it clear? Are you sure? Are you? So let's just do this, that xcm, that is equals to m by 4 into, initially that this was considered as a 0 comma 0, so this is negative of this, so it's an m by 4 into minus of r plus another mass, it's a 3m by 4 into x2 divide by total mass m. And they have said that the xcm that they have traveled a range if it did not explode, but explosion is the process due to external forces, due to internal forces, sorry, and no external forces will take part in this, so momentum is conserved, and when momentum is conserved, xcm is not going to change its position, so this xcm would be equals to r, that is equals to m by 4 into minus of r plus 3m by 4 2x2 divided by m. So this could be mr equals to minus of mr by 4 plus 3m by 4 into x2. I hope this is clear. Yes, so let's just solve this. It's a mr plus mr by 4, so it's an mr plus mr by 4, this is equals to 3m by 4 into x2. This is 1 plus 1 by 4, which is equals to 5 by 4 mr, which is 3m by 4 multiplied by x2. This 4 has gone, this has gone, and x2 would be equals to 5 by 3r. I hope this is clear. So 5r by 3 is the answer. Got this? Yes. The thing which was very technical was this location. Yes, that when say that it has been landed on the distance r from the point of projection, that at that moment you need to decide that this has been landed on the negative half, because uh, to be landed on the positive half is just not possible, because xcm is going to land it over here. I hope this is clear. Is it clear? Is it? Are you sure? Are you sure? Great. Let's work for the next question. Yes. It says the linear density of a road of length L varies as rho is equals to a plus bx, where x is the distance from the left end, the distance of center of mass from the road is. So what I need to do this, that look at this, this the linear density, let's call it as a lambda, or they have written is as a rho. So let's keep it as it is, that rho is equals to dm by dx, which is given as a plus bx. So if you observe this carefully, this is variable mass distribution system, because replace the value of x and you will be having in different masses at each segment. So this is the case of the variable mass system, and when it is a variable mass system, what I need to do is I need to just do this thing. It's an xcm that should be is equals to integration of xdm divided by integration of dm. Yes, I'm doing the same thing, just we are taking this in a form of the integration. Yes, so let's just do it. It's a rho is equals to dm by dx, that would be equals to a plus bx. So from this I can write dm is equals to a plus bx into dx. So this is xcm, that would be is equals to integration of xdm divided by integration of dm. This is equals to integration of x into dm. The dm could be written as it's an a plus bx dx divided by integration of dm, which is equals to a plus bx into dx. This is equals to it's an a into x, this is ax plus bx square dx divided by integration of a plus bx dx. So this could be written as ax, which is equals to ax square by 2 plus bx cube by 3 divided by, this is ax plus bx square by 2. Now what I need to do is, do may I have a length? Yes, it's a 4 length L. So starting from 0 to length L, starting from 0 to length L, this would be equals to it's an al square by 2 plus bl cube by 3 divided by a into L plus b into L square by 2. I hope you can do the remaining task. Does it clear? Yes, very good question. Having variable mass distribution system, please do remember this. This is required. If I know this, everything is easy. Got this? Have you got this? Are you sure? So can you do this? Can it be done? Can it be done? Are you sure? Great. Let's look at this. What they say is it's a 7 homogeneous blocks, each of length L, are arranged as shown in the figure. Each block is displaced with respect to the one in contact by L by 10. Now what they want that x coordinate of the center of mass of the system relative to the origin. Great. So how will you do this? How will you do this? This is just the mechanical approach. While I say mechanical approach, what I mean that center of mass of the first point would be at here. A center of mass of second point would be at here. The center of mass of the third point again would be at here. A center of mass of this would be at here. I hope you understand this. Yes? Sorry, it has been shifted by this something somewhere here. A center of mass of this point, it would be at this. A center of mass of this, it is at this position, and the center of mass of this is it is at this position. What you need to do is you just need to write down the masses and write down the data. Let's look. It says that xcm, so I have done, it's an xcm is equals to sigma mi xi divided by sigma mi. Yes, m1 x1 plus m2 x2 plus m3 x3 up to m7 x7 divided by m1 plus m2 plus m3 up to m7. Yes, so that I do understand that this is a longer calculation, but we don't have any such option. That's why I keep it for you guys, that you can have a reference and you can got it done from this. Yes, but the approach is this. So thus xcm of this system could be calculated. I hope this is clear. Is it clear? Is it? Are you sure? Are you sure? Great. So let's just wind it up the session over here. This was the additional questions. This was the additional questions of the center of mass. And in the next session, in the next lecture, we are going to cover the additional questions of the rotational motion. Yes. So please revise the center of mass questions as well as rotational motion questions, because we are on the completion of this unit. This is all from my side. Thank you. Have a good day. Take care. Bye bye.